I'm R. Vasandakumar, Assistant Professor Mechanical, KSR College of Engineering. Now we discuss about basics of geoenergy. The thermal energy contained in the interior of the earth is called as geothermal energy. Volcanoes, geysers, and hot springs are visible evidence of the large amount of heat lying in the earth interior. The geothermal energy is enormous and lasts for several millions of years. Hence, it is called renewable energy. Energy present as in the Earth's crust. The most readily accessible heat in the uppermost or the crust constitutes a potentially useful and almost inexhaustible source of energy. This heat is apparent from the increase in temperature of the earth with increase in depth below the surface. Although higher and lower temperatures occurs, the temperatures of the depth of 10 kilometers is 200 degrees Celsius. The molten rock within the earth is called magma. It is commonly present at the depth of about 32 kilometers on an average with the temperature of about 3000 degrees Celsius. In some places, it causes the magma to be pushed up towards the surface where the heat of the magma is being conducted upward through an overlying rock layer. The hot magma near the bottom surface solidifies into the igneous solid rock. The heat of magma is conducted upward to this igneous rock. Groundwater, which finds its way down to this rock through cracks, is heated by the heat of rock or by mixing with hot gases and steam coming from magma. The heat is transported from hot rock by circulating movement. Then the heated water convectively rise upward into porous and permeable reservoir above the solid rock. The reservoir is capped by a layer of impervious solid rock which traps hot water in the reservoir. The solid rock has fissures which acts as vents of the giant's underground boiler. The hot water or steam often escapes through fissures in the rock, thereby forming hot springs and geysers. Farmers to utilize the geothermal energy, wells are drilled either to interrupt a fissure or more commonly into the formation containing water. At any place on the planet, there is a normal temperature gradient of 30 degrees Celsius per kilometer dug into Earth. Therefore, if 20,000 feet is dug on the Earth, the temperature will be about 190 degrees Celsius above the surface temperature. This is difference will be enough to produce electricity. However, no useful and economical technology has been developed to extract this large source of energy. Next one is geothermal energy resources. First one is hydrothermal sources. It contains superheated water, steam, or both in fractures of porous rock but further trapped by the layer of immovable rock. Hydrothermal resources may be dry and pure steam with temperature above 240 degrees Celsius. However, the majority of these sources have moderate temperature ranging from 100 degrees Celsius to 180 degrees Celsius. Next one is geopressurized reservoir. Hot water or brine trapped underground at the depth of the 2.4 km to 9.1 km with temperature at about 150 degrees Celsius. It is stored under pressure of about 1000 bar from the weight of overlying rock. This type of resources can be used for both heat and natural gas. Next one is the hot dry rock or petrothermal. These resources consist of high temperature rocks ranging from 90 degrees Celsius to 650 degrees Celsius. The rocks can be fractured and water may be circulated through the rock to extract thermal energy. It is similar to normal geothermal gradient, but the gradient is 40 degrees Celsius per kilometer dug underground. Next one is the magma resources. Geothermal energy is the form of active volcanic vents occurs in many parts of the world. There is molten rock or magma present in these volcanic vents at temperature ranging from 700 degrees Celsius to 1600 degrees Celsius. Magma chambers have got hot, huge thermal energy compared to other geothermal resources. However, extracting thermal energy from volcanic vents is difficult. No technology exists to tap into the heat resources stored in magma. Thank you.